fam? Welcome back to another lesson with Mr. Biza. And in today's lesson, we're going to be talking about one-step equations. So let's jump right into it. So the first thing I want to do before I start working on these one-step equations is I want to know the different parts of an equation. So let me go ahead and write down an equation so we can break it down into parts. So here I have my equation 15x plus 4 equals 16. Now when I'm breaking it down into parts, the first number in the very front, in front of the x, is a 15. This 15 is my coefficient, the number in front of a variable used most of the time to multiply that variable. Now when I'm saying variable is just a placeholder for a number that we don't know yet. Most of the time they use the symbol x, y, or some other letter to represent some number that we're going to figure out later on in our problem. A constant is a fixed value, a number all on its own, usually separated by some type of operator. An operator such as an addition symbol, a subtraction symbol, multiplication symbol, or a division symbol. So these are all the different parts of our equations when we're trying to solve one-step or even two-step equations. So let's go ahead and look at our own equation and work it out. Now here's our first problem, x plus 15 equals 35. Whenever I'm working on these problems, I'm trying to solve for what is that variable x in these problems. What is the value of x? Now the first step I want to do to solve these problems is I like to draw a line down the middle where the equal sign is, because on either side of my equal symbol, I want both sides to be equal, because that's what the equal sign tells us, that both sides of the equation are going to be equal. So some number plus 15 equals 35. Now my second step is I want to get rid of the constant in this problem. The constant is what's being added to my x value. So I want to get rid of this part and make it go away to 0. So to solve a one-step equation, I need to isolate the variable by using inverse or opposite operations. Since this is a plus 15, the opposite of plus 15 would be a minus 15. So for me to zero out this plus 15, I have to subtract 15, because 15 minus 15 is just going to equal 0. So the only thing I'm left with on this side is going to end up being just the x all by itself. So I'm going to bring down my x. And remember, whatever you do to one side, you're going to have to do to the other. So I subtracted 15 on this side. So over here, I'm going to subtract 15. So x equals, well, what is 35 minus 15? 5 minus 5 is going to be 0, and 3 minus 1 is 2. So in this first problem, x equals 20, and we've completed our first one-step equation. Now let's go ahead and look at the next one-step equation. So in this next equation, I have negative 20 plus x equals 45. So my first step is I want to draw a line going straight down the equal sign to know that both sides are going to be equal. So that's my first step. The second step is I want to get rid of the constant in this problem. Now this one is a little bit different from the problem that we did on the last example. This time I have a negative 20 plus x equals 45. Remember, when I'm solving one-step equations, I want to isolate the variable by using the inverse or opposite operations. So in this case it says I'm adding an x to my negative 20, but I just want to get rid of this negative 20 all by itself. So this is what I'm trying to get rid of. And the inverse of a negative 20, or the opposite of a negative 20, would be a positive 20. So instead of having my negative 20, I'm going to add 20, because that's the opposite or the inverse of a negative 20. So a negative 20 plus a positive 20 will all go to 0. So I'm going to be left with just a positive x. So I'm just going to bring it down and have x all by itself. But remember, whatever I do to one side, I have to do to the other. So we added 20 on this side. So over here, I'm going to add 20. So now we have x is equal to 45 plus 20. So 5 plus 0 is 5. And 4 plus 2 is 6. So in this problem, x equals 65. So now we've completed our second example in one-step equations. so here we have our third example that we're going to work with. But this time, there is no constant that we're working with. I just have a coefficient in front of my x value. Again, remember, in one-step equations, to solve one-step equations, we have to isolate the variable by using the inverse or opposite operations. So it's saying 4 times x equals 72. Remember, if I have a number right in front of my variable, what I'm saying in this part right here is 4 times x. So the opposite or the inverse operation of multiplying would be dividing. So I want to get rid of this 4. To get rid of this 4, instead of multiplying by 4, I'm going to do the inverse operation, which is divide by 4. And 4 divided by 4 is going to be just 1. So that leaves me with just one x left. So I'm going to bring down this x all by itself. Oh my gosh, I forgot to draw my line to let me know that they're equal. And the reason that I want them to be equal is because whatever I do to one side, I got to do to the other. So since we had to divide by 4 to leave me with just one x, on this side I'm going to have to divide by 4. So x is equal to some number. Now, I'm going to have to do a little bit of division because I cannot do this in my head. So I have 72 and I'm dividing it by 4. So how many groups of 4 are in 7 all by itself? I can put one group of 4. So I take away one of those groups. That leaves me with 3 left. I bring down the 2. How many groups of 4 are in 32? There are 8 groups, because 8 times 4 is 32. So that means whenever I have 72 and I divide it by 4, I'm left with 18. So in this problem, x equals 18. So there we go. We did our third example. X equals 18 in our third example. So in this last example, I have 112 equals negative 7x. So my first step is I want to draw my line to let me know that both sides are equal. Now in this problem, first thing I want to do is get rid of any constants I have. But I'm not adding, subtracting anything from my x, so that means I'm going to be getting rid of the coefficient. In this case, I have a negative 7. So I want to get rid of this negative 7. It's saying negative 7 times x. So I'm multiplying right there. Whenever I'm solving for a one-step equation, I want to isolate the variable by using the inverse or opposite operation. So instead of multiplying, I'm going to do the opposite, which is divide. So I'm dividing by negative 7. So if I have a negative 7 and I divide it by a negative 7, that leaves me with just 1. So I'm going to have 1x all by itself. So I'm going to bring down that x. So x equals, and remember I drew this line because whatever I do to one side, I'm going to have to do to the other. So we divided by negative 7 on this side, so we're going to divide by negative 7 on the other side to see what does that equal. So 112 divided by 7. When I make groups of 7, I cannot make a group of 7 out of 1. I can make one group of 7 out of 11. That's going to leave me with, subtract 7, that's going to leave me with 4. I bring down the 2. How many groups of 7 are in 42? There are 6 groups. So that means 112 divided by a negative 7 is going to be 16. But remember, one of these is negative. So a positive divided by a negative is going to give me a negative answer. So it's a negative 16. Our last example, negative 16 is equal to x. So the variable x in this equation was equal to negative 16. So when I'm solving these one-step equations, there were 4 little steps that I took to help me figure out these one-step equations. The first thing I do was draw a line down the equal sign. This helps me remember that whatever I do to one side, I have to do to the other because they're going to balance out and be equal. My second step was I zero out that constant, or if I didn't have a constant, I removed the coefficient in front of my variable. So that I was getting rid of any number that was next to my x in these variables. My third step is remembering whatever I did to one side, I do to the other. So if I was getting rid of the coefficient on one side, I have to do the same operation on the other side. If I was getting rid of my coefficient, Whatever I did to get rid of that coefficient, I had to do the same thing to the other side. And my last step was number 4, was going ahead and solving it when I tried to balance that equation. Alright guys, so if you found this video helpful, make sure to hit like and subscribe down below. And until next time, bye!